teacher and her pen. Welcome to day 23. Let's get on with some problems. Okay, here we go with the first problem. So, the diagram shows 6 small squares made with matchsticks. How many matchsticks must be removed to leave precisely 3 small squares which touch only at the corners? So we've got the diagram, it's all made up of matches. How many matchsticks must be removed to leave precisely 3 small squares which only touch at corners? Press pause and have a go. And of course the answer is 5. So if you got rid of that one and that one, and that one and that one, and you got rid of that one, you would have 1, 2, 3 squares only touching by the corners. Of course you could have done it upside down as well. So the answer was you needed to remove 5 matches. Well done if you got that right. Okay, here you go for the second question. So before DVDs and recording and CDs, you used to have a tape. You used to have to play a tape. If you wanted to get back to the beginning, you had to rewind it. So we've got a super tape that plays for 6 hours. It rewinds 18 times as quickly as it can play. How many minutes would it take to rewind a super tape completely? So we've got a tape that plays for 6 hours, but to rewind it, it rewinds 18 times as quickly as it plays. How many minutes does it take to rewind a super tape completely? Press pause and have a go. Okay, so did you get 20 minutes? Well done if you did. Because if it's 18 times as quick, we need to divide 6 by 18. So 6 hours divided by 18. But don't forget, you don't have to divide by 18. A trick is when you're dividing by 18, you can actually divide by 6 and then divide by 3. Because 6 times 3 is 18. I could have divided by 2 and 9, because 2 times 9 makes 18. But 6 hours divided by 6 is 1 hour. And if I've got 1 hour divided into 3 bits, it equals 20 minutes. So the answer to rewind the tape was 20 minutes. Well done if you got that right.
And this one's for big boys and girls.
Okay, now this one will take a little bit of thinking. So the question is, on a digital clock display that shows hours, minutes and seconds, how many times in a 24-hour period do all 6 digits change at the same time? So on a digital clock display where you've got hours, minutes and seconds, how many times each in a 24-hour period do all 6 digits change at the same time? Okay, you're going to have to think carefully about this one. Press pause and have a go. Okay, so actually there's only 3 times. So if you've got 3, well done. Because we go from 09, 59, 59 on to 10 o'clock. So they would all change, wouldn't they? And the other one is 1959, 59, which would go to 8 o'clock, which is 20, and all of them change. Because we're going, all the other ones before this would have had a 0, and all the other ones would have had a 1, so that would never have changed. And the very last one is 2359, so it would be 2359, 59, and that would have gone to 000000, which would be midnight. So it's 1, 2, 3 times that it would actually mean all of the digits would change. Well done if you got that one right.